Hello, I'm Stefan Greber. I'm the project leader for Linux containers and one of the maintainers for Incus. And this is going to be the release video for Incus 0.7. So just before going through the very long list of new features in this new release, I just wanted to say that this is going to be the last Incus release prior to our first LTS. So as I might have mentioned in past videos and definitely have in some of the live streams, we're going to be jumping straight from Incus 0.7 over to Incus 6.0 LTS, which is going to line it up with the version of other components within the Linux containers ecosystem, specifically LXC and LXCFS. So you can expect that to happen within the next week or so. Originally, our goal was to have all of the LTSs completed by the end of March. Because of some travel I've had to do over the past couple of weeks, this didn't quite happen. So we're currently looking at getting LXCFS out with its LTS tomorrow, getting LXC out with its LTS on Monday or Tuesday, probably Tuesday, and then follow that with Incus most likely around Wednesday or Thursday next week. So that's basically the plan. With that, you're going to get 5 years of support, enterprise grade, and all that stuff for all of those releases. Now, until then, let's look at Incus 0.7. So as I said, this is quite a busy release. If we go down a bit to look at the new features, there's quite a lot, including some features I've been mentioning on and off for quite a long time that have finally made their appearance there. The main one of those is the first one on the list, which is the new concept of network integrations. This is basically a new mechanism within Incus to tell it about networks that are outside of its own control. Currently, the only thing that's supported there are oven interconnections. So that makes it possible to go from oven as managed by Incus in its own cluster to another cluster, whether it's Incus itself or it could be Kubernetes, OpenStack, or anything else. You do need some amount of cooperation on both sides. So either you need all involved parties to be aware that there is an interconnection and do the right configuration there, or you need a third-party tool to go and inject the right router ports, logical switch ports, all those kind of things within the oven config. Anyways, with Incus itself, it's now very easy to actually interconnect different clusters. You do need the right oven bits in place, so that includes some new databases and extra daemons and things. But once that's all in place, then it's very easy to have multiple clusters interconnect, which then makes it possible to pair with like multiple networks across those different clusters. So that's probably a feature that's not super well known on the Incus front to begin with, but we've had for a while support for what we call network peering, which is a way to say those two networks, even if they're on different projects, need to be directly connected and be able to route to each other directly without having to exit the network. That's also pretty good because those peerings have specific names that can then be referred to within firewall rules, as in ACLs on our side. So that feature has existed for a while. This is effectively an extension of that, which now makes it possible to peer with external networks. The idea of making this somewhat detached from oven interconnections themselves is because there could be other things that we want to connect with in the future. It could be, for example, creating a network integration to connect to networks within a public cloud. That would effectively use BGP and IPsec of some kind to set up a gateway and interact with those. So the concept is there, and it should be pretty easy to add other options in the future based on what makes sense. The next feature is something I kind of just did over an evening because I was getting tired of having to show the same examples over and over again, which is a small tool to create and run a very simple pun intended, simplestreams server. So simplestreams is a type of index files that we use for public static image servers with Incus. It's basically a number of files put on disk with two JSON files that refer to the right files with the right metadata needed for Incus to consume it. The main server of that would be at the community image server, which uses that format for all of its images. And if you want to run your own, what we've been doing so far is tell people like, well, get a web server, make sure it's got HTTPS on it, and then put your image files on disk, and then go and look at our public image server for what the metadata looks like, and write your own by hand or write your own tools to then do the publishing. That's been working fine, but everyone having to redo their own tooling is not necessarily the best. There are a few projects out there that have been written in a number of different languages that supports doing that kind of stuff. So there are other options. There are ways to run your own simplestreams server today using those different tools. But given we have a full simplestreams client and a set of Go structures and all that kind of stuff within the Incus code base anyways, I figured it would make sense for us to publish a very small tool that just uses our own logic to operate a server. So that's what we've got now. Now we've got a new tool called Incus simplestreams, which lets you quite simply add images, list images, remove images, and generate the metadata table through just a few questions. That then gets you a publicly, a file system tree that's suitable as a public image server. You can put that on a static web server somewhere and then just connect to it from any Incus machines. The next thing is around authentication. So for those not necessarily familiar with this, Incus has two main authentication methods. One is by using TLS client certificates, and one is by using OpenID Connect. TLS client certificates is what people might be the most familiar with, because that's what you use kind of out of the box. If you just do a config trust add and a remote add or something like that, that's what this is doing. Effectively, the client generates a key pair, and then you have a token to have the client add themselves to the server to set up the trust relationship. That's fine, but this effectively uses, again, TLS client certificates, which means that as part of the TLS handshake, as part of HTTPS, the client certificate is used during the handshake to authenticate itself. This works perfectly fine if you're authenticating directly against Incus, but if you're going through any kind of proxy, for example, this is not going to work. Because the proxy itself will terminate TLS on its end and then reestablish it further to the actual Incus server. By doing that, the client certificate information is lost, and Incus has no idea who's talking to it. One solution for that would be to use OpenID Connect, which then doesn't use any of the TLS stuff, but instead uses a third-party service to perform the authentication. If you have that, it works perfectly fine, no problem with it. If you don't, and you want something simpler, then now we support deriving a JSON Web Token from the client certificate. So you can use your normal client certificate, but instead of using it for the HTTPS connection, you can generate a JSON Web Token yourself, have the subject field match the fingerprint of the certificate you're using, and then sign the token itself using the private key. With that, Incus will be able to detect that, hey, okay, someone is doing authentication that way. We'll unpack it, we'll confirm that the client certificate is in its trust store and that the signature is valid. If it is, and if the not before, not after fields also line up, then it will effectively treat that identically as if the connection was done directly through a TLS client certificate, and everything else behaves the exact same way. So we've got that feature. And then still around authentication. One thing, so on the OpenID Connect front, a user will expose usually a number of claims that can be used to figure out who they are. By default, all you really get with OpenID Connect is this user is valid, they're authenticated, but as far as you knowing who they are, that's kind of up to you. The default for us so far has been to use the email claim unless it's missing, at which point we would use the subject instead. But people might be using a number of different claims, whether they are custom claims directly attached to an OpenID Connect server, which could expose some kind of employee ID or something like that, or really anything else. Now we have a config key called oidc.claim, which can be used to select exactly what claim we should be using as the identifier for the connection. And yeah, you can set it, the default value again would be email, but you can set it to the subject, or you can set it to the name, first name, last name, or any other field that's exposed by your OpenID Connect server. That's particularly useful, not only because it's what we use in our audit logs and to actually show who's doing what, but it's also what's exposed to OpenFGA. If you're doing fine-grained authorization, then that's the identifier being passed through. And the default of using the email address is not necessarily good for that, because the email address is something that can change. And if the user changes their email address, then suddenly their authorization rules don't apply anymore. Instead, you usually want to use an actual stable ID for that kind of stuff. So that's where you might be able to use maybe the subject or maybe some other field that your OpenID provider exposes, rather than using the email address. All right. Next up, I've gone through some of that in a live stream not too long ago around NUMA. But basically, NUMA is stands for non-uniform memory access, and is the way to kind of model typically multi-socket machines, but also now multi-chiplet, multi-die machines. And it effectively makes it possible to tie specific, to expose to the user, to the operating system, the physical layout of your CPUs and memory, and what CPU is connected directly to what chunk of memory, so that you don't have the system incorrectly cross those kind of boundaries, causing very high latency, as you need to either go through another chiplet on the same die or go across to another socket. So we've had support for a config key called limits.cpu.nodes for a little while. It was only applied to containers and was letting you select what NUMA node to use for the entire container. I did the first improvement by extending that to also apply to virtual machines, as well as fixing a small issue with the container implementation. And then to go further, I've also added a new config key called balanced. So if you a new value called balanced. So if you set limits.cpu.nodes to balanced, now you're gonna get your instance to use a single NUMA node out of all of those on the system, and it's gonna look at all of the different NUMA nodes available and what instances are using which to try and pick kind of the least busy one. It's a very, very basic algorithm being used. It could do with a lot of refinement as far as like picking the actual best NUMA node, but in general, it should get you a decent spread on a machine given a set of mostly similar instances. That's very useful, because now you can just put in a profile that you want balanced, and your instances will just be spread across your NUMA nodes. If you've got something like a modern AMD server chip, you can turn on NPS4, which then turns each CPU into 4 NUMA nodes to represent the 4 quadrants of that CPU. Each quadrant then having a number of cores. On some of the newer chips, it can go all the way to 32 cores per quadrant. For the 128 cores chips, but each of those quadrants also get 2 memory channels out of the 8 channels that each socket gets. So that means that by using that, you're going to actually have your instance be locked to a specific quadrant, and both for CPU and for its memory. On top of that, I've also expanded the SRIOV GPU selection logic, so that if you're passing through GPUs and you've got many GPUs in your server, it's not going to look for GPUs that are either directly on the same NUMA node or on a adjacent NUMA node within the same socket, effectively trying to limit latency as much as possible by avoiding having to needlessly cross to another triplet or even cross to a different socket. So all of that is in place, and there's just like a small example here. I'm not going to be able to do as good a demo as that example later on, but basically that example shows a total of 16 VMs running on a dual 64-core AMD system. And we can see that they're all configured for balanced, and the NUMA nodes we can see are effectively well spread across all of them. And we can even see the GPUs being picked. And if you go and look up kind of the mapping between the NUMA node and the GPU, you're going to see that mostly lines up There's not quite as many GPUs as there are NUMA nodes in that system, obviously, but it's still picking the best case for each of them, and then the virtual function being used as well. So that's the NUMA improvement. Next up, for more improvements around selecting of USB devices. So basically adding just a few more fields to what we had before. In the past, you could select USB devices for pass-through to either containers or virtual machines based on their vendor ID and product ID. That works fine so long as you don't have multiple devices that share the same vendor ID and product ID. If you do right now, I suspect it would just pass them all, which is fine in some cases, but also not what you want in some others. So now it's possible to use the directly specify the bus number and device number that you want. So that's what you would see in something like an LS USB tree, or even use the serial number if it's available. Not all devices, and really not by a long shot, all devices have serial numbers, but some do, and if they do, then you can use that. Next up, disk throttling for VMs. So on containers, we've had limits.write, limits.read for quite a while on the disk devices, which lets you limit bytes per second or IO per second for the container. Worth noting that this actually doesn't work very well for containers these days because most of the IO schedulers in the Linux kernel don't actually support IO throttling anymore, which makes that pretty useless in many cases. For virtual machines, a bit different. We've now added support for that, which goes through a QEMU throttling object type configuration, which actually lets us apply it consistently within virtual machines. So funnily enough, virtual machines go from having no support at all to having support that's actually better than what we can offer for containers these days. But this works effectively as expected. You can set read or write or both limits, and that gets applied to VMs. And the change can also be done live, I believe. Next up on the CLI front now. Up until now, the CLI, when using TLS authentication, would use a single key pair for all of its remotes. So that was the client.cert and client.key files that you can find in your incus config directory. This is fine in many cases, but there are a few cases where you might be directly provided with a key pair for a given server. If that happens, then now you can put those inside of the client certs directory, and that will effectively override any existing global, user global key pair. It's also pretty interesting if you're using what we call as global remotes. So if your system administrator has put incus remote configurations inside of /etc/incus/config.yaml, those remotes become visible to every user on the system. But up until now, there was no way to actually provide a client certificate and client key to have those remotes actually work. So while the remote itself could be globally defined, it was still using a user-specific client certificate and client key, which is not what you actually want in most cases. So now with this, it's actually possible for the administrator to also provide a client cert and client key for those global remotes, making them actually useful now. Next thing, kind of related, some folks needed to get to a client cert client key prior to actually adding any remote so that they could send the certificate over to the administrator over there. So now we've got a command line function called incus remote generate certificate, which just forces generation of the client cert client key. In the past, we would often say like just try to add like a bogus remote, like try to add 1, 2, 3, 4 or something like that, to make it actually go through the generation process as part of attempting the connection. But this is much cleaner because we can actually script that and get the files now. Then we've got a couple of improvements to other tools we ship. So the first one is to lxd-to-incus, which now supports moving users from the new lxd LTS. So it can consume lxd 521 and just import things directly from that. It can also handle systems using Alpine as the distribution for moving from the lxd package on Alpine to the incus package. And there's also a static version now of that tool being provided on GitHub. That's particularly useful when a new release of lxd or some distro comes out and we need to tweak the tool, because now you can just fetch a new version of the tool directly and not have to wait for the next incus release. So that's pretty convenient. Next up, improvements to incus-migrate. So incus-migrate is the command line tool we have that lets you import existing systems, whether they're physical or virtual machines or something like that, into incus as either a VM or a container. And in that tool, the two changes we made is that it's now a lot easier to run the tool directly on an incus system. So if your target is the local machine, you don't need to provide a URL and trust token or that kind of stuff. It can just connect to the local machine and be done, which is particularly useful when importing existing virtual machines. And also there's now an option to create a VM with UEFI being disabled and using a legacy BIOS. Again, pretty useful when migrating from existing virtualization platforms that don't use EFI by default. And lastly, we've got, and it's mostly an internal detail or most maybe relevant to administrators of image servers. We've got a couple new image requirements that can be set as image properties. The first one is a requirement of nesting being enabled on the instance. That came from the Nix community, where the Nix images work a lot better with nesting enabled. So we've got that property and it's going to be turned on their images soon enough so that effectively the user is told to turn on security nesting prior to the instance being started. The second one, which is requirement of CD-ROM agent, that was added for all of the Red Hat derivative images, which don't support 9P and so can't get access to our agent the normal way and require that extra CD-ROM drive being added. So for those, that requirement has already been set on the images, which means that at creation time, they will refuse to start unless the user first adds the needed disk, at which point they work perfectly fine. So that's it for all the stuff in Incus 07. There's actually a fair bit more things that are still being worked on towards the 6.0 release, but they tend to be kind of smaller features, smaller things. I don't really like there being a big feature gap between the last release and the LTS. That's why we've actually kept the timeline so close with 07 this week and the LTS coming a bit later next week. So that there's not going to be too many changes. It's just an opportunity to fix any bugs that people noticed in 07, add a few more features that just didn't quite make it for 07, and then call that 6.0 and have an LTS. All right, so let's try to demo some of that stuff, starting with probably the most complex one, which are the network integrations. So if I switch over to a terminal and go to here, it's a bit small, but I don't think I can do too much about that given the amount of information that's actually needed on screen. I might be able to just resize those guys a bit and then zoom in the ones on the left. So, oops, I'm trying to just line that up a bit, but that's going to be tricky. There we go. So basically what we're looking at here are 3 clusters. So there's 3 incus clusters, each with 3, I'm going to give up on this thing blinding up, I think. Yeah, close enough. Anyways, so 3 clusters, each with 3 servers. So we can say the first one is called AZ01 server 01, then AZ02 server 0201, and then AZ03 server 01. And they each have another 2 servers in each of the clusters. So that's a total of 9 machines, effectively, set up as 3 clusters. And they are each on their own network. They each have oven set up, and they each have 3 instances, I believe, running. So if we go look at the instance list, you can see 3 instances on that last cluster, 3 instances on that second cluster, and 3 instances on the first one. And we can see the instances are actually also spread between the 3 servers in each cluster. As we can see, they're on completely different network. So we've got 10.179.180 on the first one, 10.228.182 on the second one, 10.98.33 on the third one. And what we can see on the right is actually the first instance on each cluster trying to ping the next instance. So the first one is trying to ping the one that's below it, the one in the middle is trying to ping the one at the bottom, and one at the bottom is trying to ping the top one. That's obviously not working. They're on completely isolated oven networks. Even though they have working internet connectivity, they don't have any way to talk to each other whatsoever. That's normal behavior. That's what you normally get with 3 independent clusters. Now let's set up an integration. So those clusters, so each of the cluster has its own oven deployment. And then I've got a oven interconnect deployment going across the 3. So effectively, each cluster has a redundant database layer for their northbound and southbound databases. So each of the 3 servers participates in that with a raft quorum in place. And then the first server in each of the 3 clusters participates as one of the database servers for the interconnect, and the interconnect also has its own northbound and southbound database. The idea there being, you can lose a server in any of the clusters, there's no impact. You can lose, well, there's no impact within the cluster, and there's no impact across clusters for the interconnect. That's the idea. And then I've got a server in each, I believe, currently acting as a oven interconnect gateway, which actually relays the traffic between the different clusters. So that stuff is not really Incus specific. That's just oven setup for this kind of environment. So the first thing we need to do is create an integration. So do integration create. I'll call the integration oven region, and it's of type oven. So we can do that here, and then do the same on all 3 clusters. One thing that might be worth mentioning is that there's actually no kind of existing relationship between those clusters whatsoever. Like they don't have, there's no, like Incus clusters are completely standalone. They don't have any way of having control over another cluster. So that's why I need to do the exact same thing on all 3. They're completely standalone clusters. Then we need to set a address for the northbound and an address for the southbound. If you're using TLS, you also need to set those keys with the client certificate, client key, and CA. But in this case, I'm not using TLS to make things a bit easier. So now I've got an oven integration defined. The integration is called oven region, and it's got its northbound and southbound database configured on the first one. Now I need to go and do the same thing on all 3. And you could pass everything in just in the create command. It just would get kind of long, so I figured I would do it this way. Okay, so that's done now. If we go look at network integration list, it's there. It's currently not used by anything. Okay, that's fine. Next, we need to actually make use of it. So let's do create a new peer. So what we're saying here is we're gonna peer network default, create a new peer called region, and the target is oven region, which is the name of the integration. And this is a remote peer as opposed to what we used to have before, which is a local peer. So add that, okay, created, and then do it on the other 2. And you're gonna see on the right that things start pinging now. So what that actually did behind the scenes is when the first one was created, it looked up within the oven deployment, specifically the interconnect, and it created a new transit switch. So in this case, it's called ts-incus oven region foo. And once that got created in there, then it also created matching router ports and logical switch ports within the local northbound database. So we could see them here. We can see all 3 availability zones, all that stuff got created here. And then the same thing on the other 2, where they actually noticed that the transit switch already existed, so they didn't do anything about it, and then just set up their own peering. And once that's done, then with the right oven configuration in place, which advertises routes and learns routes across an interconnect, then each of the network starts to be able to interact with the other. And that's how we connect 3 clusters together. All right, so what do we have next? Image server management tool. All right, So for that one, I need this one. Okay, so I've got a basic web folder here, which is actually exposed publicly as this, and is currently empty. There's nothing in there. We're going to turn that into a new image server that we can then add with something like that. Protocols, single stream. Okay, so here we can see that it just added it, but if we try to actually list it, it's not going to be happy. Okay, that's fine. Now, let's actually make that useful. So I said there's nothing in there right now. So let's do incus simplestreams, and then I've got an image that's a Red Hat 9 VM image that doesn't have any metadata. So we're going to need to do that first. So we can use the generate metadata command, and then just generate ourselves a new. So I've got here the file here, a new file called rel9.exe. Operating system name would be Red Hat Enterprise Linux. Release is 9, it's a default, and the architecture name is that. It gives us a generated description, which is fine. So let's just use that. And now we've got the tarball. Once you've got the metadata tarball, then you can actually add the image by passing in first the metadata tarball and second the data. So if that was a container, the metadata tarball would still work the same way, but then the second file would be a squashfs or a tar.exe tarball of the root file system. When you add that, it's going to actually hash both of the files and then generate the index files that are needed. So it can take a little bit, depending on the size of the image being added. In this case, I don't remember, it's like about a gig large or something like that, so it can take it's going to take a few seconds. It also is actually copying the data into the tray, which in my case is probably another source of slowdown here, because that web tree I'm publishing to is actually based on CFFS, which involves replication and a bunch of other stuff. So that's going to take a tiny bit. Can check, it probably doesn't have an index yet. Nope. I think to take a bit longer than I expected. Might have gone with a smaller image. Let's see. I actually don't remember exactly the size of this thing. So, well, it just completed now. All right. So if we look at what we have now, we've got a tree with both the tar.exe and the qcat we generated. The file name here is actually the hash is actually the hash of the image as incus sees it, and then it generated for us both the index and the images JSONs. You can actually use incus simplestreams and do list, which then looks at the index and tells you what you have. And there's also a command to do verification. That's going to take a little while, where it actually goes through all of the files in the index, make sure that all of them exist, they've got the right size, and the SHA-256 also lines up, which is good for verification purposes. Anyways, this is done, so now we can see the image just fine, and we could now also start to use it. We can see one funny thing here because I used the full name of Red Hat Enterprise Linux instead of just something like rel. So that gets encoded as one of the aliases, which might be a bit funny to have to type. So you would probably have gone with rel instead as a way to avoid that. All right, maybe just show how to remove the image. So you can do remove and then the fingerprint and. Nothing is in there, and we just have empty index files, and nothing is on the image server anymore. So anyway, that's a pretty easy way to just run an image server with a few images and just publish things that way. All right, next up, JSON Web Token. All right, let's try to get that one going. So if I go on my own machine, okay, I'm in a demo project. I've got one instance here, that's fine. I think I actually played with that earlier, so I should probably clean things up a tiny bit. So that's my trust store. Let me just remove a couple of the certs in there that I don't need. Okay, so things are nice and clean now. First thing I'm gonna do is generate a new OpenSSL certificate. Let me see if I've got the command handy. Yeah. So that will generate an RSA 4096 key and cert. Okay, so certificate and keys are both there. And then I'm going to use a small tool that we've got in our own test suite. People might have different tools. They might have their own tooling to do that kind of stuff, but we've got a small tool called TLS-to-JWT, which takes the client key, client cert, and the issuance date. So I'm going to use now, and how long it should be valid for. So I'm going to use 2 minutes. So this spits out a big string, which can then be used for authentication. So if we were to use, let's try to just use my local system, which listens on the network, and then I want to list the list of projects. Okay, so if I just do that like this, it's gonna fail with not authorized. It's fine. And then if I do it with the authorization header with the new token as a bearer token, this is still gonna fail. At least it should. It would be a bit worrisome if it didn't. Come on, copy paste. Should make the tool actually give us a line break at the end. That will make things a lot easier. Anyway, let me try the other way around. So yeah, there we go. So that's the token. We passed that big chunk here. And try that again. Oops, there we go. So this is failing, currently complaining about an OIDC issue. That's fine. That's simply because I'm using OIDC and not just basic TLS on my server. So if I remove that, now we're back to normal, not authorized. That's kind of expected because I did not actually trust that certificate yet. So if we do add certificate, with the client cert and marked as a restricted certificate for the demo projects, and I run this again. There we go. So basically what I did is I generated a key pair. I derived a JSON Web Token from that I'm then using with curl to authenticate against incus. And initially that failed because the certificate was not trusted by the server at all. Then I trusted that certificate and now it's working. And it will stop working in, I don't know, a minute or so once the 120 seconds expiry hits. So that's how the JWT stuff works. Let me just clean things up. So remove that, config trust list. Gonna remove the trust entry. There we go. Just to make sure if you run it again, not authorized, it's gone. Also needs to actually set the issuer, the OIDC issuer again. I don't actually remember the value right from the top of my head now. Let's see, what did it complain about? Complain about that. So that's probably the right value. Oops, there. Okay, so back to normal. And now to actually look at the next thing, which is configurable OIDC fields. So that's why I just put the OIDC value back in place because I'm actually gonna need it for that demo. So my local system supports OIDC authentication. I actually have a way to connect to it, not locally, but over the network using OIDC, and as that remote called s-dakara. If I do that right now, you can see that my username as reported by Incus is s2gib@s2gib.org, which is my email address. Now, if I was to change that to say, so that's the new config. If I set OIDC claim to name, then it's gonna use that. Is it first name? Is the other one? Nope. I don't actually remember the exact fields that are allowed. But if you do email, then that works. If you do the subject, then that works. So basically any of the normal claims can be used. And if you unset it, then you're back to the normal behavior of doing the email address with a fallback on the subject. So that's why you can actually set this to any OIDC claim that's coming from your OIDC provider and use that for authentication and actually end up exposing it to something like OpenFGA for authorization. All right, so next would be NUMA handling. Okay, so for that we need a machine with NUMA, which I conveniently have somewhere, this guy. That's one of our test systems. It's an Intel machine with, we can see 2 NUMA nodes, and it's got like 6 cores, 12 threads per NUMA node, I believe. The memory should be similarly split, kind of half and half between the 2 nodes. You can actually get more, some of that info as well from Incus itself with Incus info resources. So it's starting Incus and then poking it for that information. If we go look up here, there we go, NUMA. So 64 gigs per node, as we can see up here. All right, so let's set that thing up. So first, let's do a quick init. Sure, let's just pick the defaults, that should be all right. Okay. So that gives us a working machine. Now we're gonna want to launch a VM. So let's try Ubuntu 2204. Give it 4 CPUs, and we're gonna want to have it tied to nodes. Let's manually do this one on node 0. So call it V1. And that's what you get to actually pick. You can do, this one's going to be specifically locked on the first NUMA node. Then we can do a second one specifically pinned on the second NUMA node. Then we can do one that's just, well, do a couple that are just randomly spread. Okay. Well, that's not going to work well, huh? This would actually have failed the pinning, so let me just stop it. And then we'll move it back to balanced. Basically what happened on V3 here is it wouldn't have found a matching NUMA node because there are not that many. And just went on with a warning in the log and picked and just randomly balanced it. So let's do that one as balanced. There we go. Okay, so now that gives us 4 VMs, 2 that are specifically pinned, 2 that are balanced, so just pinned by Incus itself. And then let's do, oh, whoops, actually I forgot some. Sorry about that. I just noticed I messed something up a bit more. This actually were containers instead of VMs. I actually did mean to mix both, I just didn't mean for those to be containers. So let's clean all that stuff up. And then gonna move things back to being VMs. All right, so ignore all of that, let's start again. So new VM called V1 for CPUs and pinned onto CPU node 0, so the first NUMA node. Then we'll do the same thing for the second VM and then to balanced after that, and then we'll do the same thing with containers to kind of show you how that stuff works. So okay, V2 goes on 1. Here we go, and then we want balanced for V3 and V4. V3 and V4. Okay, so that covers the VMs. Now, the VMs are not necessarily the most visuals as far as what we can have. So for containers, what we'll do is we'll do one with absolutely no limits. Okay, because containers are a bit different. Containers, if you don't set a limit, they get all the CPU. VMs, if you don't set a limit, you just get a single one. But here we can get to actually play with that a bit. So if we do CPU with the C2 pinned on node 0, C3 is going to be pinned on node 1. Okay, then we'll do C4 pinned on nothing, so just the random balance that Incus does. And we'll do C5 with a CPU limit. Okay, so that should be enough for a sample. Let's see. So we want a list of those. We want to see their status and type. So that gives us that. And then we want to see limits.cpu.nodes. And we want to see volatile.cpu nodes, I think is the name. Yeah, there we go. So what that shows us, what we've got running right now, what NUMA pinning we asked for, And for those that are balanced, what value got picked. So we can see it's split 50-50, the instances between the two NUMA nodes, which is kind of what I expected. Where it gets kind of interesting are for the containers. So if we look at the first container and we go, do we have LSCPU in there? We do. LSCPU will show us, it's not actually that readable, is it? Do we have nproc? Yeah, we've got nproc. Okay, so this one gets us all the CPUs. So we get all 24, which means it shows across both NUMA nodes. Now, if we go look at C2, which has the same config, so no, it doesn't have a CPU limit. Actually, I should add that to the output. Hold on, limits.cpu. Yeah. Okay, so we can see it still doesn't have a CPU limit, but now it has a NUMA node limit. So if we go look, it's got 12. That's because, obviously, it's stuck to a single NUMA node. There's only 12 threads on that NUMA node, so it's limited to that. We'll see the same thing on the next one. And then for the balanced one, again, we're going to get just 12, still from a single NUMA node. And if we go look at the last one, this one is not only limited to a NUMA node, but limited to 4 CPUs within, or 4 threads within that NUMA node. So that's all applied there. On the VM side, nothing is visible inside the VM, really. If we go in there, we're going to see a normal 4 CPUs, nothing weird. You can't tell from within the VM really what's going on. The main thing you might notice is that your memory access are actually fast. If you've got a misbalanced machine in the past where your VM would be across 2 NUMA nodes, either for CPU or for memory, then some memory access might be quite slow. With this logic in place now, that's not going to be the case anymore. All right, so that's the NUMA handling. Next up, passing through USB devices with more options there. I don't know that I've got anything interesting as far as devices that support serial numbers. So let's see. That's also a machine with a bunch of USB stuff. So maybe. Let's see the USB bus. USB, okay. Interfaces. Okay, so some of them have serial is empty, serial is empty, serial is empty. So that's not super common for the serial number to actually be filled in. So I can't show that part. Let's maybe try with the bus number and device number. That might work. So let's try, not this guy. Okay, there's a YubiKey here. So maybe try passing that through. So that YubiKey is on bus address 2, device address 4. Let's see if we can pass that to maybe one of the VMs. V1, USB, bus num, I already forgot. YubiKey is, what did I say? Bus 2, device 4, okay. Bus number 2, device 4. The name of the device, let's call it UB. Okay, and that got added to the VM. So let's see. We don't have LSUSB, which is always a bit unfortunate. It's USB tools. I never remember the name of those packages. Either USB tools progs or something. USB tools like that, maybe. USB prog. Okay, where is it? USB. USB utils. Okay. I really wish there was some kind of standalone on those kind of packages. Cool. So LSUSB, and we don't have it passed. Why didn't it locate it? Oh, I think I know why. Those VMs have very, very limited driver support by default, so you need to install extra modules and that kind of stuff for that to work. Maybe if we pass it to one of the containers, we might see something in bus inside of /dev. I'm not super convinced this is even gonna show up. No, it's not. But anyway, this is how that works. I can't show the serial part. This was with the bus and device address. So there's more flexibility around USB pass-through. It's especially useful if you've got like a machine with a number of serial devices. That's where this stuff really becomes the most useful, because they're all going to have usually the same serial chip, so the same vendor product ID, but not the same serial field, or not, at least not the same device and bus number. One thing to keep in mind is that device and bus numbers could change across reboot, so that's not necessarily the best either, but at least gives you a bunch more options. All right, so this guy was throttling for VMs. Okay, let's try and get that one going. So again, if I take my first VM, and let's do a random read into that now, 4 megs, count 100. So if I read, we're currently reading at a bit over 400 megabytes per second. That's fine. Now let's apply some limits. So override on V1, the root device. I want limits.read at 10 megabytes. What's the syntax for that stuff now? Limits.read invalid value. Is it just 10 megs? Yeah, it's just 10 megs. Okay. Try that again. This is super fast because we probably hit the cache. So where's park drop? Yeah. Okay. So we most likely just hit the page cache here because it's a read we already did. So if we drop all caches and then try that again, this is slow. That's good. That's what we want. So that should be well, reading 400 megs at 10 megs per second. So it's going to take us, solid 40 seconds. But effectively, that's how that works. So that's in this case, a byte limit applied on read. Write is a bit harder to demo because of file systems and everything, unless I pass an extra block device that I can just trash by writing to directly. But the exact same mechanism works on both reads and writes. Has it been 40 seconds yet? We'll see how close we actually get to the 10 megabytes per second. There might be other things in the background also reading from the block device because this is a running VM. And so it could have impacted a bit. Okay, no, exactly 10. So that worked. Cool. So that's this guy was throttling for VMs. Next up are per remote client certificates. How am I gonna show that one? It's, I can easily generate another cert, so I can do that. Okay, cool. If I go to my local system here, okay, and I do, am I trusted myself? I'm probably not. Yeah, I guess let's do it that way. So if I generate a new certificate, there we go. And then I trust that certificate. So add certificate client cert. Okay, and then I try to add my local system. I already have a localhost remote. Okay, I'm a local system. This actually sends me through the old remote authentication, which I didn't mean to. So let me just force of type TLS. Okay, now it wants a trust token because I'm not trusted on that system. That's fine, that makes sense. And this is still gonna be true. So if we look at the trust store right now, we do have that client certificate being trusted in there, but obviously my client is not using that. I can fix that by using the new feature and moving that client cert in there. So if I do config incus client certs, and it's the remote is called localhost, so it's localhost.crt. And then the same thing for the key. And I add the remote again, and it just works because it's actually used that other certificate, and we can access it just fine. And then I can remove that remote and delete the key actually has been deleted already, and just remove it from the trust store. There we go, all cleaned up. So that's how that works. You can create that folder, put the keys in, add the remote. It uses the new key instead of your main key, and that works fine. If you were to do it globally, you could do it by just putting it instead of /etc-incus client certs instead, and that would work fine. The remote generate certificate, I can show that it's going to complain in my case because it already have one. But if you didn't, then that would just kick in the generation at that point. So that's pretty simple. lxd-to-incus, I'm not going to show that now. It still works the same way, just we support 521 LTS now and support running on Alpine. On the incus-migrate front, I can show the slight difference in behavior. So for that, you need to be root. You need to run incus-migrate. So now it asks that questions. The local incus server is the target, and you can say yes or no. If you say yes, then it just moves on and immediately uses the local server. If you say no, then it goes through the normal steps of asking for the URL token and all that stuff. The other difference is, and I can do this by just using the local one. Oops. Let's clean that stuff. Yeah. Okay. If I do a virtual machine, default foo show provide, I don't know, did now. Okay, and now it asks, does the VM support UEFI booting? If you say no, then it automatically set the CSM, so the legacy BIOS compatibility mode on and turn off secure boot for you. So that's the other difference. If you say yes instead, so if I go here, foo, okay, if I say yes, then it asks whether I want secure boot or not with default on for secure boot. If you say no, then you get config with the secure boot disabled. So that's the main change on that one. And that's pretty much it. The only last one would be the requirements. I can also show that pretty easily. If I launch, say, a CentOS, I don't know, CentOS 7 VM, I guess, that should trip it. So it's gonna download the VM. Actually, CentOS 7, I think, might not need it. Might have been a bad example. I should have used something like Rocky Linux 9. Let's see. So it's downloading the VM image, unpacking it, and okay, no, actually it does trip it. Now it says failed creation. The virtual machine image requires an agent config disk to be added. So that's actually at startup time that this failed. So you can just go and do device add on that VM and do, say, an agent disk. So source agent disk, agent config. And then if you start it, oops, C7, then if you start it, then it works fine. So that's how that works. It effectively applies like another very early check so that you don't end up starting VMs that have no chance of actually working. And that's going to be starting up, and after a while should actually give us a working agent and all that stuff in there. Yep, there we go. Cool. And I believe that's it for this release. Quite a busy one. There were quite a few features in there. I mean, took me pretty much an hour to go through everything, which is a bit long for a release announcement. But yeah, quite a lot. There's a bunch more things that are gonna come as tweaks and fixes between now and next week when we do the LTS. But I would encourage everyone to try incus-07. Also, if you find any issues or anything in there, please make sure to let us know, so that we have a chance to actually fix a bunch of that stuff before we do the LTS release next week. That's it for incus-07. If you've got any questions, feel free to leave them down below. Go on the community forum, ask us there. And I'm gonna see you quite shortly with the LTS release. Thanks. Bye.